The Earth is a complex system. The greenhouse effect, for example, plays a major role. Without it, the Earth's surface temperature would be at around -20 degrees Celsius. An example of a positive cycle is the water vapor feedback loop. So what's the effect of all of this on planet Earth and on us? To figure that out, we have to look beneath the Earth's surface to thermohaline circulation. A particular section of this global conveyor belt is known as AMOC. Here, warm water from the equator first moves up towards the poles until it becomes colder and more salty, therefore sinking, and then moving back towards the equator. The actual process is a bit more complicated, but the principle is the same. Now, due to recent changes in Earth's climate, AMOC has been weakening. Two basic mechanisms explain this weakening, which is primarily occurring in the polar section of AMOC. When abnormally warm water enters the polar section of AMOC, it tends to resist sinking more than colder water would, thereby reducing the strength of the cycle. The water discharged from ice-laden areas such as Greenland is not as salty and therefore not as dense. Before, saltier water would more effectively sink in the polar regions, but after the release of less dense fresh water from the glaciers, this effect was reduced. By 2100, AMOC's strength is projected to decrease by 1/3 of its 1961 to 1980 value. This is because AMOC is being pushed towards a tipping point, represented by the peak of the hill, after which destabilization would rapidly accelerate. But why would all of this happen? Let's return to the idea of Earth being a system. At the geographic equator, AMOC directs heat towards the poles. That means ocean heat transport at the geographic equator is directed north. To maintain hemispherical equilibrium, atmospheric heat transport at the geographic equator must be directed south, which explains why the meteorological equator is to the north. Yet a shutdown of AMOC means that this equilibrium becomes perturbed as ocean heat transport severely weakens. This interplay between oceanic and atmospheric heat fluxes is known as the Bjerknes compensation. This is what is thought to have happened almost 13,000 years ago during the Younger Dryas period. Temperatures in Greenland may have dropped up to 10 degrees Celsius due to AMOC shutdown. As a closing notice, the effects of AMOC shutdown are not yet fully understood. Some places might actually benefit. Understanding Earth's climate ultimately involves looking at different parts of the system and seeing how they interact.